Alright, here's a quick take on how to do that rationalizing the denominator stuff that we only briefly saw in class. 12a was an example of this. We have these radicals, they're in the denominator, and that calls for us to do what we call rationalizing the denominator, getting rid of that radical in the denominator. That's the synonym for it. To do it when it's, like in part A here, f of g of x, if there's a radical that is added or subtracted, or it's part of some term comparison, or a couple of terms that are added and subtracted, we do what's called multiplying by the conjugate. And so that means to multiply by radical x plus 1, which is the conjugate to radical x minus 1. It's just changing the sign of the added terms. So the result that we get from the numerator is pretty easy. 1 times the radical x plus 1 numerator, well, radical x plus 1. The denominator, as we FOIL that out, multiplying those two together, radical x times radical x, if you remember, is x. So that's where that first term comes from. Then the rest is you get a negative and a positive radical x, which cancels. And here's a nice simplified version. So that's really the heart and soul of multiplying by the conjugate will get that radical to disappear. That's always what's going to happen. So that's the reason we do that operation. Then g of f of x, we have this radical with 1 over x minus 1 in it. The property you need to remember is that you can split a radical up when there's a fraction to take the radical of the numerator and denominator separately. So split them up. Radical 1 is 1. The denominator now has a radical, so you have to rationalize it. Again, this is an old school type thing. It's actually not necessary anymore with calculators and computation devices we have, but it's still required in certain textbooks, so we're going to go with it, and on various tests. The multiplying, in this case, since there's no radical plus or minus something, or something plus or minus a radical, it's just a radical itself. You just multiply by the radical numerator and denominator. So when there's an absence of an addition or subtraction of some radical term, you just multiply by the radical itself in the denominator and numerator. So if I do that, the top, of course, is radical x minus 1, and the two identical radicals, when you multiply them together, the end result is the contents underneath that radical. The radicals cancel. So we have our final result there. Now the next video is dealing with having all those fractions of, a denominator with a fraction in it. So hang tight, look for that next video. I'll help you there.